Yay. Yes, it was one of those settings within the computer, my own computer, that was blocking Zoom access to, certain files, certain folders. But I found it. So here we go, off and running, right? You can nod, say hello, whatever, as we go here. Maybe I think I'll start on the outside. Look, that is the word problems. That's okay, all right? And Bill made $50 more than Jim. We want to write an expression. So it kind of like, sometimes you might almost say, for word problems, often you go to the end and that tells you what you're trying to do, what you're looking for, right? At the very end. Write an expression for Bill's income. Somehow we're going to describe the amount of money that Bill made in terms of what Jim made. So here I've made up this problem that says, we're going to let J stand for however much Jim made. What kind of expression can we put together that describes what Bill made based on Jim's? All right, so if it's going to be related to, whoops, that pen must have been open all night, excuse me. Always like to have a couple handy here. If that was Jim's, what do we do to Jim's to make it look like, to make it describe Bill's? Well, Bill made 50 more than Jim. Add 50. This is the expression we're trying to come up with, or 50 plus J. Addition, you can switch the order. That's okay. Multiplication also, that's a rule or property that we'll talk about specifically later. That's what I'm hoping you come up with, okay? And, all right, a little more complicated one here over on the right side. Got a container, holds nickels and dimes. I just about really do have that in my car, all the car change. Especially these days, the little stores, they like you to bring your change. Anyway, so the number of nickels is 5 less than twice the number of dimes. Here I go. Write an expression for the number of nickels. Okay, so I'm going to come up with an expression that describes the number of nickels in terms of the number of dimes. So, I can pick a letter. I didn't say any particular letter, but I'm going to say, I'm going to use the D for the number of dimes. So the nickels is related to this quantity. The number of nickels is 5 less than, that should mean I'm going to subtract 5 from something, okay? The number of nickels is 5 less than twice the number of dimes. Twice the number of dimes, what does that mean? I think I mentioned this the other day. Twice just means 2 times, not like dimes squared, all right? So 5 less than that, twice the number of dimes minus 5 would be 5 less than twice that number. So we're trying to get out of that one. Whoop. Meanwhile, well, hopefully I'll find that one pretty soon. Okay, so that was that. Yeah, I appreciate your commenting on what was hard for you for the week or something like that. And that helped me choose a couple things to put up here to warm up with. All right. Yeah, top of that pen's probably underneath my stand here. Oh, well. All right, this one related to a problem that one of you asked me about yesterday comes out of section 1.4, multiplying and dividing with integers. So it's an order of operations problem. Simplify it. There's no solving. We're not trying to find it equal to something. There's no variables to solve for, right? I'm just going to simplify it. We ought to be able to come up with a single number by doing all the operations there. I asked this question, well, what's the first thing? I can just answer in your own mind, or if somebody wants to chime in. What's the first thing you're going to do in this problem? What's the first operation, you might say, that's required here?
-5 plus 3.
There you go. Yes, I heard whoever said parentheses, and yes, that's the -5 plus 3. So we're going to work from inside out. You know, if you've got multiple layers, then you work from the innermost layer and work out. Now here's one you might not think about. What's the very last thing that you're going to do? Can you look at this whole thing and just kind of say, the last thing I'm going to do is?
Negative outside the brackets.
Yes, good for you, whoever did that. This one means we're going to do all this other stuff, and whatever we get, we're going to take the opposite of it. Great. All right, so if we're going to do that, I always just rewrite everything, okay? So here goes. What is that, -2? All right. What's the next thing you're going to do?
Exponents.
Exponents. Okay. Now, before we go too far, I want to point out this kind of problem is designed almost as a trap, a trick. There's something visual in there that easily causes you to make a mistake. Oh, 4 minus 7, that's just 3. This is saying 7 times whatever else all this turns into. That's multiplication before the subtraction. Keep an eye out for that kind of situation in one of these problems. There's something, like I say, visual about that. It's like, oh, you just think, oh, that's easy, I'll do that part. But you can't. It's 7 times something else first. All right, so here we go. The exponents, I'm going to square. This means -2 times -2, +4. And I don't really need the parentheses anymore, but if you like them, you can put them in there. I just said now it's 7 times 4. All right. Now, still inside brackets, I have a subtraction and a multiplication. I just mentioned we have to do the multiplication first. 7 times 4, 28. Hopefully, the more comfortable, fluent, you might say, with your basic math facts, like that practice scan, you know, multiplication tables. Yeah, easier life will be, put it that way. All right, inside 4 minus 28. Way left on the number line. So what's -24?
That.
And opposite of negative is positive, 24. Hopefully you got there, or hopefully that makes sense and you followed me as I briefly look for the, oh yeah, I'm gonna grab the cap to this pen, pardon me as I crawl on the floor. All right, here we go. All right, that's that. Hey, a couple of bits of business before I forget. Yeah, I do have my recording working today. Sorry about that for the last couple of days. So it'll be posted later today. We're going to cover 1.5 today, half of the fractions sections. And that means 1.6, the other part of fractions, won't happen until Tuesday. And so if you look on the calendar, I have bumped the due date for the fractions 1.5, 1.6 section, I think until Thursday of next week. Rather than being due Tuesday, as though we had covered it all today, I pushed the fraction one a couple days later. Give you more time because we won't have gotten to it yet. All right. So good for you. Looks like almost everybody got through the 1.2 homework. It's what I needed. And I've contacted a couple of you. Maybe you didn't quite get there yet. It's all right. All right.
Can we do one more of the brackets one that we just did?
Okay, sure. Let's do something like that. And I was going to pull something off of a actually homework page, but I'm going to just have to make something up here. All right. So here we go.
I have one that we did yesterday.
Oh, you want to do one? Okay. Yeah, give me one. Go for it.
Negative a bracket 1 minus 2.
Oh.
Yeah,
Okay.
remember this one?
This was the same one. I actually worked off of that and just changed the numbers in the one that
Huh.
we put up there.
So do you want me to change it or do you want to do the same one?
Oh, we could do it again. All right. One minus.
Okay.
And what was in here?
Negative 1 plus 5.
Yeah, that was the squared again, right?
Yep, you're good.
I try not to call you out when you ask questions, you know, of me personally, but Kayleen is making it clear. She was the one who asked this question yesterday.
Yeah.
So, anyway, if you guys want to give that one a go real quick, huh? Try that one on your own. Maybe I'll just hang back here for a minute and you guys see what you can do and how far you get all on your own. But it's got all those same issues that I talked about in the one I made up.
Oh, that's the one.
So just like that one, you're going to start in the middle. Watch out for this. You can't do that thing first, you know.
-1 plus 5 is, okay, so we're gonna go down,
All right.
down, and then -1 minus 4, so I mean 5,
Say again. Now what's next?
4, 2 brackets. Okay, wait a second. Okay, -1, 2, 4, yes, okay. So negative the exponents.
Okay, let's see. I wonder, nobody's trying to get in. Good. Who's checking? If you don't mind.
Oh, I'm sorry.
That's okay. Was that Gwen? Yeah. She just muted herself, I guess. I scared her off. That's all right. You were telling us all, but we're going to square this, right? Here, I did the parentheses again instead of my multiplication dot. Either way works. That's what you should get to next. Now we do have multiplication. Math facts, 2 times 16.
32.
Right? Does that make sense? So far, so good. And starting from 1, but -32 gets us to -31. But opposite of that is positive 31. Okay. So that's almost as tricky as we're going to try to make these in this first section here. We're going to throw a little division here in a minute. All right. If that's okay, I'm going to move on. Here we go. I think I sort of got distracted yesterday or sidetracked with questions or something and really didn't address division of integers. It's the same rules that we want to recognize that we talked about for multiplication. If I have 2 positive numbers, I guess, and I'll talk about it right now, right? This arithmetic notation we will move away from very quickly. By the end of this chapter, we really won't use the division symbol anymore. We'll be writing a division problem like this. This represents 10 divided by 5. It's going to be the, sort of, we're going to make fractions out of division. So if we're dividing 2 even numbers, there I did it again. We're dividing 2 positive numbers, we get a positive result. If I'm dividing 2 negative numbers, negative divided by negative, we still get a positive result, just like multiplication. And similarly then to the multiplication, if I have a negative divided by a positive, it's a negative result. And I could flip that around. And I get a negative result. So it's the same rules as multiplication. Same signs results in positive. Opposite signs results in a negative. Okay. kind of like I said, for subtraction, mathematicians might say you can always think of subtraction as adding the opposite. We can see maybe when we work more with fractions that division like this can always be thought of as multiplying by a fraction that has that number on the bottom, like 10 times 1/5. You know, so division can be thought of as multiplying by a fraction. So this is basically what you have to get out of this section for division. All right, that same signs, positive, opposite signs, a negative result. And we don't need the answers, you know those answers. And maybe I'll throw one of these up here then real quick. And my little dots sometimes aren't big enough. Let me know if you don't see those. Like that one will look like a minus sign, and I meant division there, okay? So here's an order of operations problem that includes some divisions. Still using that arithmetic symbol for division. All right, so no real groupings there, just the parentheses are containing the negative signs. I emphasize this, you know, we don't want to put symbols and operations right next to each other. You need the parentheses. So here I have a division plus another division. So no groupings, no exponents, but now I'm down to multiply or divide. So I'm going to divide those two different things. What's 52 divided by 4? Everybody's favorite long division, right? Or maybe you're doing this.
13.
13, I think, right? A 13. Positive divided by negative. Negative 13. So that's what we want to get out of that, is the sign there. And negative 32, or 32 divided by 8, 4. But it's going to be negative divided by positive, so it's going to be a negative 4. So I'm going to use those parentheses. So now we're just down to an addition problem. Negative plus more negative. Farther left. Negative 17. Thank you. Yeah, good. All right. Let's go on. Change my notes. All right, here we go. 1.5 fractions. One 1.6 is often a little more challenging because that's where we do the add and subtract. We have to do the common denominator thing. 1.5 gets us into multiplying and dividing fractions and sort of presents the idea or definition. So as a fraction represents parts of a whole object, right? Dividing a whole object into numerous same-sized parts. And so we write it in this form. Some two integers, basically, one number over another, to be thought of the top number divided by the bottom number. And we'll mention it right now. We can't divide by 0. It's undefined. So if we're writing a fraction, it assumes the bottom number is not a 0. It just doesn't mean anything we don't know what it means mathematically, to divide by 0. How many zeros go into something? Okay, so then some rules, basically. Here's that initial fraction, and I'm talking about the idea of building an equivalent fraction. All right, like what if I've got this fraction 3/5, and for some reason I want to turn it into a fraction that has a different number on the bottom. That's usually in the bottom is what we're usually interested in. I'm going to be able to use the term numerator is the top value, and denominator is the bottom number. Denominations, right? What's the size of the pieces? What denominations? What are the denominations of bills in your wallet, right? Denominator, what size pieces did you cut it up into? All right, numerator, denominator, got to understand those two terms. So an equivalent fraction, if I start with this one, as long as I multiply the top and the bottom by the same number, it's like making them both proportionally bigger, I get an equivalent fraction. So if I take this one and multiply it by 2/2, all right, and I get to a new one. Well, here we're already talking about how do you multiply. You multiply the top two numbers together, which is, I guess, what I wrote here, the way I wrote that. As long as I'm multiplying the top and the bottom by the same thing, it's legal. 6/10 is another equivalent version of that original value, 3/5, right? Maybe something maybe more obvious. If I have 1/2 and I multiply top and bottom, say by 3, I get to 3/6. We can still see how that's the same as 1/2. So this is the idea of building an equivalent fraction. There are going to definitely be situations where we want to change one or more fractions into an equivalent form so we can do something else with it. We add and subtract usually. Okay, get rid of that. So just a little picture thing is just nice to motivate or describe this multiplication process, right? Talking about multiplying. Here I took a whole object and I divided it into 4 pieces. I was going to write a fraction to describe that. It would have a denominator of 4 equal sized pieces. Sure, they're all equal, right? And here I'm going to highlight 3 of them. I've described 3 of those 4 pieces, 3/4. Well, what if I want to multiply this fraction by another fraction? Multiply it by 1/2. I want 1/2 of all this stuff. Picture's kind of nice because I can go, oh, 1/2. I'm going to cut it in half. Now look what happened. I made 2, 4, 6. Now I have 8 pieces. And half of them, say just the top half, right? So I have 3 out of 8 now instead of 3 out of 4. The picture is supposed to help us see that from here to here, we multiplied those 2 pieces together, 3 times 1, and we multiplied those 2 together, 2 times 4, and that's what we do with multiplying of fractions. You multiply the numerator values together, and you multiply the denominator values together, just kind of straight across, all right? So if I have 2/3 times 5/8, we'll talk about simplifying in a minute. I can come up with the product of those 2 fractions just by multiplying the tops together. 2 times 5 is 10. 3 times 8 is 24. There is the product of those 2 fractions. Yes, we're going to do more with that one in a minute. We have to simplify it, right? So this is the gist of multiplying. Watch out if I've got a negative times a positive. You still have to keep track of your signs, right? Negative times positive, my result will be negative. But 5 times 7 is the number 35. 6 times 8, 48. There is the product of those 2 fractions, negative times positive. All right. Well, start with that sort of abstract thing with the letters again. if I've got a fraction number in the numerator,
Slow down just a little bit.
slow down, you say?
Yeah, just a little bit.
That's fine. Good.
Thank you.
That's good. Let's say I've got some fraction and I recognize that the numerator and the denominator both have a similar factor in those two numbers. It's kind of like going backwards from what I did a minute ago with the equivalent fraction. Let's say I've got some fraction 10 over 12, right? And I recognize that that is 5 times 2 over 6 times 2, right? It's like there's the C, and the A and the B are the 5 and the 6. 2 over 2. That's the whole thing. That's the number 1, right? 2 divided by 2, it's a 1. So here, by doing this, I'm really sort of multiplying this by 1. If I multiply by 1, I don't change it. It's kind of a rule that we'll maybe talk more about a little later, but I can, we say, cancel those factors of 2 from both the numerator and denominator and simplify this fraction to 5/6. What we're doing is kind of going backwards from that equivalent fraction. We really are, these two fractions, the original 10/12 and 5/6, are equivalent. This one has been reduced, or you've probably heard that phrase, lowest terms. These two terms, you might say top and bottom, are the lowest or smallest numbers that they can be and still be equivalent to the original one. You will always be expected to look at your final fraction answers and decide whether it is in lowest terms or to put it in lowest terms. Try to simplify it. I've got to let somebody back in here. Try to simplify it. Often, I think mom will tell you that, you know, reduce the lowest terms, put your answer in final answer lowest terms, but if it doesn't, you should just expect to do it, okay, lowest terms. So if I've got something, if I've got a fraction like that, there's 15 over 25, right? And I want to look at it. Here's where those common multiples, right? Divisibility tests are going to come into play. Is there a factor that I can divide both of those terms, both the numerator and denominator by? And I'm trying to come up with numbers right now that are easy enough to recognize. And you don't have to write this all out. In a second, we'll talk about that. But that's 3 times 5, and this is 5 times 5. So that common factor of 5 can be canceled out. That's like taking away the 1. So the reduced version here is 3/5. And just double check, make sure there wasn't something else in there I missed the first time I reduced it. That would be the lowest terms. Now this process I definitely show for teaching explanation. Sort of the shortcut, if you get comfortable with this in your mind, you can just say, oh, I see I can divide them both by 5s. And so what folks do is in their head, they say, if I divide this by 5, I have a 3 left. And if I divide this by 5, I have a 5 left. And so now I know my final answer is the 3 and the 5. That's totally legal, okay to do. A shortcut like that. Yes, thank you for slowing me down. That's always important. And so, now, here's a multiplication problem. Back to multiplying those two things together. I'm going to do this a couple different ways just to show you a process that's okay. So here we got to, we did this one a minute ago, 10 over 24. All right. 2 times 5, 3 times 8. Now I have to look and say, are there any common factors there that I can cancel out? Well, those are both even numbers. How's that? I can tell they're both even, so I could divide them both by 2. Let me know if you get confused here, but if I divide this by 2, it leaves a 5. If I divide that by 2, it leaves a 12. So at this point, I'm up to 5 divided by 12. I'll look at that and say, are there any other common factors I could cancel out? And the answer is no. 5 is a prime number, no other factors, right? So I'm done. I've reduced that to lowest. Say again?
So I just have a quick question. Fractions have never made sense to me. I never learned them. So this is you trying to reintroduce this to me all over again. So I may be totally on the wrong path here, but it looks like when you go into the multiplying of 2/3 and 5/8, are you always gonna reduce it down to its lowest terms? It's never just gonna be, this is the answer, it's 10/24. Is that what I'm understanding?
There will be times where the product you get can't be reduced, okay?
So if it's possible to reduce it, you always should reduce it to its
Yeah,
smallest.
it's kind of like the convention expectation. You know, this is an equivalent fraction. It means the same value, but yes, we're gonna push you to always reduce.
Okay.
I've noticed also, I pay a lot of attention to the directions. Sometimes they'll say to simplify and other times they won't. So especially in mom, just pay attention to the directions in there.
So if
That's,
it's simply asking you to multiply, then that's where it would come into 10/24, whatever, that would just be the answer. But if it's asking you to reduce, that's when you're gonna get it to its smallest form.
here's where I'm saying, I think mom was, say good to you by often reminding you to simplify, but I would say you'd be safer to always simplify.
Okay.
Especially on paper problems, right? Hand in homework worksheets, you know, I expect you to simplify.
Okay.
Try. I mean, you know, if it was a 10-point problem and you didn't reduce the lowest terms, you might lose 1 point, something like that. You got this far, that's great. We really wanted you to go the 1 step further. All right, I hope that was clear. You know, don't want to make it mean, but yeah, we expect you to simplify. The second way I said I was going to do this, whoops, getting ahead of myself. 2/3 times 5/8. This is like both those numbers are on top and both those numbers on the bottom of one big fraction. Notice, okay, I can cancel that common factor right now if I recognize it between these 2 different fractions, right? These are both going to be numbers on the bottom. And the 8 is really a 2 times 4, so there's a 2 in there already, right? I could divide them both by 2. I'm going to probably confuse you if I try to talk about it too much. But if I see, oh, I can divide a 2 out of both of these right now before I multiply. This is often a process that folks prefer because then they get really close, if not actually to the reduced answer before they multiply. You know, now when I multiply, I'm going to get 1 times 5, 3 times 4. Oh, I'm there already. I found as much as I could simplify before multiplying and getting a big number and then having to work on it. So if you recognize things that you can cancel out, even from here to here, right? Sometimes maybe it's even within the first fraction. You could simplify one of the fractions, but as long as it's numerator against denominator, you're canceling within, you know, the same factor from top and bottom. That's okay to do, as long as it's just multiply, multiply, multiply. You can do more of that. Can I erase? Let's see if I can make up something good here. All right. Now, just imagine. Of course, if you've got calculators, I know it makes it so much easier, but we're trying to get you to understand this and be able to do this in your head. 9 times 24 is going to be a big number. 16 times 18 is going to be a big number, and then I have to start over and try and simplify. Are there any common factors, between top and bottom? Oh my gosh, I didn't even mean to do that, but even within this fraction, I could simplify this one fraction. What's a common denominator? Think of a bigger number. Not common denominator, what's a common factor? What factor goes into both 24 and 18?
6.
I think I heard it. How about a 6? If nothing else, a 2 or a 3, but 6, right? They're both divisible by 6. If I divide this by 6, I left with 4. Divide this by 6, I left with a 3. So that was just simplifying one of the fractions before even multiplying. But now I'm going to look between them. Between this top and this bottom, right? Common factor is 3. I could cancel the 3. Divide this by 3, leaves a 3. Divide this by 3, here's you got to be careful to be neat, right? Leaves a 1. And similarly here, these are both divisible by 4. Divide this by 4, leaves a 1. Divide this by 4, leaves a 4. So I'm canceling common factors before I get those big numbers. They just happen to be ones. I made this one up. 3 times 1 is 3. 4 times 1 is 4. Take a look, make sure you didn't miss anything, but that's lowest terms already. It's lowest terms. So that's often considered convenient, a nice thing to recognize, be able to do before you multiply. If you can simplify before you multiply, you know, that's usually saves you work at the end.
So I'm still very confused. I'm so sorry to have to stop you again. I don't understand how, okay, so 24, yes, is divisible by 4 6 times. I don't understand how it turned into a 1. I just.
24 over 18. The first thing we did was recognize they were both divisible by 6. Somebody suggested 6s.
Okay.
So I divided this one by 6 and that left a 4.
Yeah.
And that left a 3 here. Okay?
Okay.
So now our problem is backing up, right? 9/16 times 4/3. This one's now turned into 4/3.
Okay.
Is that okay? Right?
Yeah. Mm-hmm.
So now I'm kind of like starting over again, seeing, is there anything else I can cancel? Oh, so as long as I'm looking between top and bottom, I can cancel the same value from both the top, the numerator, and the denominator. Here I noticed the numerator here and the denominator here are both divisible by 3.
Mm-hmm.
So I'm going to divide both of these by 3s.
Okay.
I made this leaves, divided by 3 leaves a 1.
So you're cross multiplying, right? That's what we call that.
No, we're
No, cross dividing, maybe?
cross, yeah. I try to be careful. Cross multiply refers to a very specific operation.
Okay, never mind then.
In mathematicians' mind, it's something called proportions, and part of an equation.
I'm having a hard time too, so I'm just trying to get in my brain as well.
Well, so I won't use that term. If that's what you know,
Maybe cross cancellation.
cross.
Yes, thank you.
There you go. I think that works. We'll buy that one. All right. So, and similarly, I think it was Glenn, maybe whoever was talking before. Similarly, here, both of these were divisible by 4s. So I got to there. And now,
Okay.
okay. Now I just did it up here. That's why I was saying you got to be careful. Don't get messy, because I canceled and then canceled again. And you know, if writing it like this is safer, better for you, you know.
Yeah, when you rewrote it out, explaining it like that, breaking it down a little bit more for us simpler folks, that helps me a lot more.
All right, Steve, do your job. Come on. No, that's perfect. Yes, exactly what we need to hear. All right. Hey, a couple unusual ones, perhaps. Let's say 5 6 times 4. How are we going to do that? Turn the 4 into a fraction. What's the fraction version of 4?
4 over 1.
Yep. Now, yeah, so whether you write it out or you can just think of it in your head, right? This is 4 is the same as 4 divided by 1. So now it looks like two fractions multiplied together. You're ready to do the multiply. Can you see anything to cancel first? Since we've just been talking about that?
Can't, the 6 and the 4?
Yes, some 2s. Do you recognize?
Two.
So here I'm going to do this. Is this okay? Divide by 2 leaves 2. Divide by 2 leaves 3. Not too messy yet. And that's all I see. So now I'm going to multiply and say 10 over 3. So point of that one was just how to deal with an integer value there, a whole number, right?
Is there any way to simplify that problem?
You know, we did it here, but 10 divided by 3, you know, it doesn't work out evenly.
Okay, I didn't think so, but I figured I would ask.
But it does point out this
So
is
that's an improper fraction?
exactly. We will almost never use mixed numbers. Sometimes at the end of a word problem, it's a little easier to talk about, you know, 1½ cups rather than 3/2 cups, and you might choose to write it as a mixed number. But in algebra, we never, you can't do a string of things with mixed numbers in the middle of them. So we
Is
always
it
leave them.
an improper fraction because there's a larger number on the top?
Yes, that's that definition. Yes.
Okay.
So there's nothing wrong about an improper fraction. Okay, leave the improper fractions. Leave them like this. Don't try to say 10 and 3 1/3. Leave them like that. If you changed it, I'd figure it out. You can leave them just like that. Okay, one more.
Can we do another one of those?
Pardon?
Can we do one more of those so everyone gets cleared? Everyone understands.
Yeah, good idea. Thank you.
Thank you. I'd appreciate it as well.
In like, oh, how about, let's see. I was going to give you something to, how about that? So you're going to take that 40, that integer, whole number, write it as a fraction.
Give us a second to figure it out so we can do it too.
What a
Please.
concept. You should be a teacher. I know, that's good too. I have to stop myself and make you do it. Yeah, so I wrote it to 40 as a fraction. I did try to make up something where you could do some canceling. Now we're at the end. Some simplifying before multiplying. You recognize it. How am I doing? Using up the time here. Okay, can I go ahead then? I recognize that 40 is divisible by 8. Do you see that?
Mm-hmm.
So if I divide both of these two by 8, this turns into 1 and this turns into 5. 40 divided by 8 is a 5. Maybe you just noticed it was divisible by 2 and you cut it in half. That's still getting you partway there. But now if I multiply 7 times the 5, 35, 1 times 1. If you end up with that kind of answer, it's not wrong. But so you can just write like that or write 35.
Okay.
So,
That was my
sorry
next
to
one.
interrupt again. How did you get 5 to go into 8? I don't understand that. Oh, so
Divided by
simply,
8 is 5.
So when you're canceling or simplifying, you're dividing the numbers by the same thing. You're dividing. I divided 8 by 8 and got a 1 left is my quotient. I divided 40 by 8 and got 5. So simplifying is dividing those numbers by the same thing. You're dividing.
Sorry, it doesn't make, sorry, so you're dividing 5 by 8 and getting 1?
No. Here I had, 40 is the product of 5 times 8.
Yeah.
Okay, so when I was over here looking at the original fractions, right? Now I was trying to think, can I divide those numbers, any of those numbers by the same thing? Can I divide a number on top and a number on the bottom by the same value?
No.
Well,
With full 4.
you could do a 4. And what I jumped to was, oh, actually I could divide this by 8 and I can divide that by 8.
Okay.
Now, if you recognize the 4,
Oh, okay.
say if you recognize 4, well, if I divide this by 4, 8 divided by 4 is 2, right?
Mm-hmm.
40 divided by 4 is 10. Now I could keep going and I'd get 70 over 2. And then you might recognize, oh, those are still even. I can divide them again. But right now I could say, oh, I have a 2 and I have a 10. I can divide those again. I can divide both of those two numbers by 2. That's good. So now I'm here. You liked this better before. Now I'm at this point, right? Oh, look, I can divide those two by 2. And that get me to that 5 and a 1, 7 times 5. If you might say sort of bottom line, if you are uncomfortable for a while, you can always just do this. And I did that in my head fast, and you take more time. But now I have these numbers, and now I have to start thinking about, can I cut them in half, or whatever? Can I divide them by a bunch of stuff? I have to try to reduce this as much as possible.
Okay.
Okay. This last few examples was trying to recognize that you can do it before you multiply, and that saves you the work at the end, the trouble at the end. All right, let's see. One last weird one, okay? And I'm not really going to get to divide today, which is all right. We'll come back Tuesday. You guys are asking good questions. I'm aware fractions is one of those topics where folks started having trouble somewhere last time they did math. You know, fractions are often confusing for folks, and so we want to take all the time necessary here. Okay. Anyway, this is
have Zoom class on Monday.
Pardon?
Do we not have Zoom class on Monday?
No, it's technically it's Martin Luther King Jr. Day. It's a national holiday, and there's no classes. I can't require you, and so feel free. You can send me messages. I'll be around. I'll answer homework questions if you want. I was just going to say this example. It's very similar to what we just did. Only this thing in the parentheses is a little more complicated than that other integer example. But we want to do the same kind of thing. This is the fraction times this expression. Make a fraction out of that expression. It happens to be negative. Those things are on top, 9 times an a, whatever a variable a might be. And now I have this thing that looks a little messier. So if I was just multiplying straight across, I would do 11 times 9 and get 99a. I'm going to do that, okay?
Can't we simplify it to be?
Well, we've been going both ways, so I was doing this first, and now I was going to simplify, okay? Yes. Or, yes, the simplify is recognizing that I could divide the 9 and the 3 both by 3. But divide them by 3. Divided by 3 leaves 1. Divided by 3 leaves 3. Now I have 11/3 times that, and that turns into 33a. Whoops. I'm sorry, that should have been a 1. Whoops. 33a over 1 or just negative 33a. Notice at this point here, we would try to divide both of those by 3. Divide them both by 3 and get the same 33. So this was, as an example, just because it looks a little messier with the negative and with this variable stuck in, but it's really similar to the last couple. I am out of time. You guys may be out of time, right? And so do your best to work through the 1-3 and 1-4. It is due, not Monday because of the holiday, but it is due Tuesday night. You could show up Tuesday with questions if you're really still stuck on 1-3 or 1-4. We'll finish up with division and start add subtract on Tuesday of fractions. Okay, so
Thank you.
you're
Yeah,
welcome.
Thank you so much.
See you later. Have a nice weekend.
See you Tuesday.
Have a great weekend. See you Tuesday.
Thank
Okay.
you.
See you later. Bye.